to look at types of computers. And after looking at types of computers, we go ahead and look at computer hardware. So I've shared my screen whereby I have slides or a presentation about types of computers. And that is what we are going to start by discussing. So we have different kinds of computers or types of computers. We can categorize them depending on the size in terms of their physical structure, the size, the physical size. We can also categorize them depending on their capacity. Capacity, this shows their processing capacity in terms of speed, in terms of memory, and all that. So we can categorize computers either depending on size or depending on capacity. And when we categorize or classify computers according to size and capacity, we get 3 types of computers. The first type is what is called the mainframe computers. The other one is the mini computers. And the other one is the microcomputers, or what is called the personal computers. So we start with the first type, which is the mainframe computers. And these are large, powerful computers that are used by many people or users at the same time. They are typically stored in large organizations. So what we mean by being used by many people at the same time, this means one computer being used by different people or users at the same time. For instance, you can, in an hospital setup, you can have the mainframe computer stored at a central place. Then in each department, we have terminals or desktop computers or laptops or whichever kind of other types of computers. And all those other computers are connected to the mainframe computer. So the mainframe computer provides the capabilities of maybe the processor, the storage. So in case maybe I'm registering a patient, so I enter using my desktop. So the information is processed and stored in a mainframe computer. At the same time, we have a doctor who is seeing a patient and is typing their diagnosis, requesting some tests and all that. Doing that using his or her laptop. But the processing of that information, the storage of that information is stored in the mainframe computer at a central place. So that is where I'm putting that they are really large and they are powerful and they can be used by many people at the same time. And you find such kinds of computers in being used in large organizations. They are located in a central place, the way I've said, and they are accessed by users via computer terminals or other computers placed at different locations and connected to the mainframe computer. So you can see the example I was giving. Another example I can give is what we are having currently, like in our institution. Like those, maybe the September intake might not have experienced this, but those students who had the April intake, that time of exam, we sent you a link and all the students received the link for the exam. So each student was using their own terminal, either a mobile phone or a laptop or even a desktop. And they were typing that exam. Where was that the results and even the link or the exam itself held? It is held in what I can term as a mainframe computer. It's in a central place and many people are accessing it at the same time and they are even in different locations. So such kind of a computer, because it is large and it's also powerful in terms of the processing speed, is a mainframe computer.
Excuse me, Mwalimu.
Yes.
Excuse me, Mwalimu.
Yes.
There are some of our classmates who are stating that they don't have the link to the class.
Tell them.
Yes.
To check their emails. I only sent one link last week. So that link is recurring. So every Monday at 5:30, click on that link. The way I've set it, I will not be sending link every Monday. I've set one link for 12 occurrences.
Okay.
Maybe that is maybe the information they didn't have.
Let me ask them to.
Yes, tell them to check their emails and click on that link I sent last week.
Okay.
Then you type on the chat whether they have succeeded.
Okay, okay.
Okay, so that is the example. You can still see my screen.
Yes.
Yes.
Yes. Then I was saying another example of mainframe computers is what is called supercomputers. And supercomputers are extremely powerful mainframe computers used in scientific and engineering applications. So this is a special category of a kind of a mainframe computer, which is called supercomputers, because it is majorly used in the scientific world where data is the people scientists deal with data, and you can see data actually is usually in huge amounts, or data takes a large space, and even to process data as a scientist or as an engineer, you require some special types of software for you to do that, and that is the reason why specific and special kind of computers are used, and they also need to be large and powerful. And those special type of computers is what we are calling them supercomputers. So in the early days of computing, mainframes were huge computers that could fill an entire room and even a whole floor. You remember when we were looking at the history of computers, when we talked about the ENIAC and the UNIVAC. So we said they were huge. So that is now the idea of what a mainframe computer is. That is, its size was really big, and they could really fit take up large space. But we are saying the size of computers has diminished while the power has increased. The term mainframe computer has fallen out of this in favor of enterprise server. You will still hear the term used, that is mainframe computers, particularly in large companies, to describe the huge machines processing millions of transactions every day. So when we talk about a mainframe computer, you know the structure or even the physical look of a computer. But you realize that even though the term mainframe computers continue to be used, what has been left in terms of the physical look of a mainframe computer is what we call the servers. So the example I've given, you'll find that in your institution, the institution maybe where you work, there's a server. So the structures or the infrastructure which makes up that server is what can be termed as a mainframe computer. Even the example I've given for ourselves when we were doing exams, even when we are teaching, the link I am sharing with you for the class, and you being enabled to join the class, that is not being hosted on my laptop I'm using. It is not being hosted on a desktop somewhere. It is being hosted in a server room, in a server. And that server is what today we can term as a mainframe computer. And it's all due to its high processing capabilities. And the term now it's being used in most of the institutions is enterprise server. You can see that is what can be seen as a server. Mainframe computers can handle thousands of connected computers and process millions of instructions per second. So I believe from what I've explained, you can connect how a mainframe computer can work. Many computers connect to it. Like I said, for our exam, during maybe 3 hours, we had over 1,000 students being connected to the same server, and they were taking different exams. They were posting, they were typing, so different instructions. So all those instructions were, millions of instructions were being processed, and you could not realize any delay, because once you instruct, I want to send, I want to submit, I want to save, I want to do what, I want to move next. That is an instruction maybe you have given in terms of what you want to do. And another student might have given another instruction at the same time. So you find that this type of a computer is processing those instructions so fast because of its power in terms of processing capabilities. Supercomputers, as I've said, these are type of computer, usually they cost hundreds of thousands or even millions of dollars. And although some supercomputers are single computer systems, most are comprised of multiple high-performance computers working in a parallel or as a single system, and they are best known as supercomputers as built by Cray supercomputers. So you find supercomputers it's an assembly of parallel systems built together, or many computers connected together, so that when they are put together or when they are connected together, the processing speed is increased. So that makes it how a supercomputer works. So that's how a supercomputer looks like. You can see there are different computers put together, and we see they are the fastest, they are the most powerful, and they are the most expensive. So if you can have a chat maybe with your ICT department manager of how much a server costs, you'll be amazed, you'll be surprised. They are actually very expensive. And that's the reason, as a person or for your individual use, it will not be possible for you to buy your own server. Servers, you find them in institutions where several users will require to use the server. Several huge amounts of data needs to be stored. Different instructions are to be sent by different people or users. So you require kind of a computer which is able to do all that. And that is where you will find such supercomputers in organizations. Then we have the mini computers, and the mini computers are medium-sized computers. They are between the mainframe and the micro. So the medium kind of computers is what is called the mini computers. And they are also used by many users at the same time. And these ones, you find them in small organizations. We have said that mainframe computers, you find them in big organizations and even in governments, because that is where you find many people dealing with computers at the same time. But for a small organization, it is possible to have a setup of like a mainframe, but instead they have what we call the mini computers, because the number of people being served by that computer and the instructions being issued is not as large as when it is a big organization or even a government office. So mini computers, you find them in small organizations, but they have pretty more processing speed than the micro. And that is the reason we are saying that they can be used by many people at the same time. So they can also act as a server. So that's how a server looks like. A server is a computer that has been optimized to provide services to other computers over a network. Servers usually have the powerful processors, as I have said. They have lots of memory and large hard drives. And the next type of computer can fill an entire room. I think you have heard about what is called the data centers, or you have of recent past you have heard about the clouds, or data is in the cloud, whatever data is in the cloud. In real sense, it's not a cloud per se, as the way we look at the clouds in the sky. What it means by that phrase is that data is stored off-site and in a place which people or even the organization itself does not want to disclose. So there are companies, ICT companies in place who solely their work is to provide storage spaces. And when you visit those companies, those are the companies you'll hear they are providing the cloud. They are the owners of the cloud. So the cloud is not a cloud, it's just a server room. So you find many computers in that place. And then in the data center or those computers in the server room, you'll, as an institution like AIU, we can hire a space, a storage space, maybe for our examination, maybe for our student details, for anything maybe we want. And therefore we'll be paying a service to the owner or to the vendors of that data center. So we will be assured of security of our data, and we will be assured of accessibility of our data. So there's no time you'll find data is not accessible or maybe network is down and all that. So that is what is realistically what is called a cloud. It is put as if it's an imaginary kind of a space. However, it physically exists. There are companies out there whose their work is to provide storage and processing, powerful processors just to institutions. So that institutions focus on their mandate. Like we will not have a very strong ICT department, even though we require support, but we will focus on teaching and we will focus on research and we will focus on community extension. Then we hire storage space, we hire the infrastructure from a vendor who provides the data center. So they'll give us what we are calling an optimized space to other computers of our network. This has to be provided of our network. So for our computers in our university, to access the cloud, which is the data center, those computers have to be connected to a network. So this is an example of a server, a web server. So you can, even not only for institutions, even individuals can hire spaces and they can hire services from a data center or what we call the cloud, provided maybe you have the economic power. So that is how it works, and that is how a server works. You can also see how it looks like, and basically there are many processors, big large hard drives put together, so that you are given the processors to process the instructions, and you are given the storage space to store any data, or to store any data you want. So that's how a server works. Coming to the third classification, that is the microcomputers, and these are small scale computers that fit on your desk, and they are meant to be used by one user at a time. So look at what we have discussed for mainframe computers and the mini computers. We said those two categories, they are large scale computers, mainframe being the biggest, the largest, and the mini being the medium size. But one common thing among the two is that they allow different users to use a computer at the same time. But for microcomputers, we say they are small scale, and you find them, they only allow one user to use it at a time. So what we usually interact with most of the times, the top computer in your office, the laptop you have in front of you, the mobile phone you have, the terminals, the iPad you have, all those are types of microcomputers, because you realize that if I'm using it, no one else can use it until I'm done, and maybe I give another person. So that is what that is an example of what we call a microcomputer. And why is it that? So because the size and also the processing speed can only allow one person and few instructions at a time. compared to what we have discussed previously. Examples of microcomputers, we have like workstations, and workstations is a microcomputer with enhanced graphics and communication capabilities. So a workstation is whereby a computer you network it so that it can communicate with other computers, and also it can have what we call enhanced graphics. Graphics in terms of you can use it to draw, you can use it to color, artistic work. So that is what we call workstation. A desktop is also a microcomputer, and a desktop is a personal computer that is designed for portability. That is, portability is the ability to be moved from one place to another. So, and that's the reason why you can move a desktop from one table to the other. So it is portable. And that is where the term desktop comes from, that it fits on the top of a desk. And it is portable, that you can move it from one place to another. The expectation with the desktop systems is that you will set the computer up in a permanent location. Desktops, you cannot, in terms of moving, it's not like a laptop. So if you set up a desktop in one place, it can only work from there. If you have to move it, you'll have to set it up in another place. So desktops are permanently, they are set up in a permanent location. So they don't give you that ability to move it from one place to another whenever you want. For you to move it, even though it's portable, for you to move it, you have to go ahead and set it up again in another location. Most desktops offer more power, storage, and versatility for less cost than their portable brethren. Portable, it's like now the laptops we have, and desktops are more powerful than laptops because they have more power, they give you more storage, and also they are versatile. And also, you find they are less costly than their portable counterparts. You find laptops are more expensive than a desktop. And that's how a desktop looks like. I believe we have seen, and even desktops are usually less expensive than laptops. However, they have more power and they have more storage than the laptops. That is how a setup of a desktop looks like. A desktop computer is a personal computer designed to be in a stationary location where all of its components fit on, or they are under a desk or a table. And I believe you have seen such kind of setups whereby you set up your desktop either with some of the components under the table, like in image 1, or maybe all the components can fit in one table on top of it. And even nowadays, even the involvement of computer, even the desktop computer has really changed. From what we are used to, like the first image, this one, you'll find there is a CPU which is separate, a keyboard, speakers, and even then the monitor. That is what is common. But now technology has changed. Like now in the second image, this image, you'll find a computer coming already with inbuilt CPU. So this monitor already has in it inbuilt CPU. So you don't need a CPU which is outside. They also come with what we call wireless keyboards. This keyboard is not attached, does not have wires, ports to be attached to the computer. So it is wireless. And even the mouse, like the way we have a wireless mouse for our laptop, we have desktops which are coming now with the wireless mouse. You don't need a wire to connect to the CPU. And even the speakers, wireless speakers. So you just need the Bluetooth device and you are able to connect the speakers to the desktop. So such kind of a setup is now the latest trend of the desktop technology, whereby you have everything inbuilt on the computer. The monitor, the CPU is inside, the keyboard is external, yes, but you don't need wires to connect to it. The mouse is outside, yes, but you don't need wires, and that is a very good setup. There isn't a lot of components on the desk, such that the way you know that wires are coming, maybe like the first setup, the wires to come all the way from here up, you need a power cable, data cable, network cable, and many other cables. But now with this technology, everything is in one place, so you don't need such kind of wires. So that is the desktop computer. Then we have the laptops, and laptops, actually the genesis of laptops, Apple CEO Steve Jobs was the founder of what we call the laptop technology, the technology itself. That is a computer being able to fit into your lap. That is where the word laptop comes from, that a computer which can sit comfortably on your laps, and it's fully designed to fit there. So, and you had the new MacBook, which is still there in the year 2008. Of course, it was bigger that time. Nowadays, the size has really largely reduced the size of the MacBook Air. But the idea of a laptop started there. Laptops are also called notebooks, and they are portable computers that integrate display. So they have in them the display, that is the monitor. They have the keyboard, and they have a pointing device or trackball. They have a processor, they have a memory, they have a hard drive, or in a battery operated package, slightly larger than an average hardcover book. So a laptop, also called a notebook, has really integrated everything in our computer. And I think that is since it came earlier before the desktop technology I've explained of everything being inbuilt. I think that idea of a desktop being inbuilt, they are trying to borrow that idea from the laptop technology. So laptop has really integrated the display, which is the monitor, the keyboard is together there, a pointing device. You can use a laptop without a mouse, whether connected mouse or wireless. It provides you with somewhere for you to move, to point. It also has a trackball. Whoever has a laptop, they can look at the keyboard. There is usually that red knob. That red knob is what is called a trackball, and it also acts like a pointing device or as a mouse. So all those help you to navigate or to move from one place to the other, to click. And clicking is the process of issuing an instruction. Then the processor is also there, is integrated. The memory is still there, and the hard drive. And one thing with laptops, they are battery operated. Laptops, they work with a battery, and that is the advantage, because now with a laptop, power can go off, but you continue working with your laptop, because the battery which is there has stored power, and therefore that power in the battery is the one which powers the laptop. Compared to a desktop, you know that using a desktop and power goes off, you have to wait until power comes back for you to continue using it, because it does not have that provision of a battery to store power. Then all these are examples of what we call microcomputers. And you can see they are small scale, and they're usually used by one person at a time. There's the personal digital assistants, what we call the PDAs. The PDAs are tightly integrated computers, and they're often used like flash memory. They use flash memory instead of a hard drive for storage. These computers usually do not have keyboards, but they rely on touch screens, technology for user input. PDAs are typically smaller than a paperback novel, They are very lightweight with a reasonable battery life. So they also have a battery, and they are slightly larger and heavier version of the handheld computers. We shall have the handheld computers. And what I'm showing there is an example of a PDA, or what we call the Palm computer. Then we have the tablets. The tablets are also, it's another example of a microcomputer. And a tablet is a thin, lightweight mobile computer that has a touch screen. So that is, and those are images showing what is a tablet. So you can have a tablet with a stand. You can have the convertible tablet. So these are examples of what we call a tablet. And it works like, it has everything. It has a processor in it. It provides you somewhere to type, either using the touch. It can be touch screen like the first one, or it can even have a keyboard, a detachable keyboard like the second one. Then we have the handheld computers. These are computers small enough to fit in one hand. And where I've seen these handheld computers being used is mostly in security and procurement, where they do a lot of stock taking. I believe you have seen these barcodes. Like an organization which is dealing with maybe a commercial organization or industry, whereby they need to track the barcodes of particular goods and goods or products. It's not possible to record, you see, those barcode numbers, and you keep track of them. So this handheld computer is useful in such instances. We have it also in the library, and this one we use it for stock taking, because you cannot go when you are doing stock taking, you can't pick one book after the other and all that. So you just need this handheld computer, and you just point it to the barcode, and it reads and it provides the details of that product or that book. So even in a health sector, or maybe in a hospital setup, it can also be a good one, whereby like stock taking, you want to take stock of the drugs, or even maybe when you have patients and they are using smart cards. Maybe the smart cards, other than the chip, there are other smart cards which use the barcode. So the handheld computer can be very useful, whereby you scan the barcode of that card, and it provides you details of that patient, provides details of the dependents and everything, and even more details about what is the eligibilities of that patient, or what does that card allow. So that is what we call an handheld computer and how it looks like. We have the wearable computers, and this is the latest trend in the computing, the wearable computers. Essentially, the common computer applications in them include the email, the database, not media, calendar, or scheduler. They are integrated. So you have like and this one is, maybe you have seen it in the market, the watches, which are, it's a computer but in form of a watch. You can use it. You can use your watch to send an email. You can use it to receive a call. You can use it to get Google Maps, and you drive using it. Cell phones or mobile phones are also examples of wearable computers. So it is good to see, like now, a woman wears the Teams Motors prototype of a wearable personal computer. And also for divers, by the way, they also wear wearable computers to give signals the depth that person has gone, in case when they are down the sea and they want to send a message to the other people, they can do that. So it is a wearable computer because you can wear it and you use it the way computers are used. So, but one thing with the wearable computers is that it has limited capabilities. Like you see, it only allows you to send an email or to receive an email, to make a call, to maybe to schedule a meeting. So maybe you are wearing it as a watch, and it gives you an alarm that you have a meeting at 5:30, you have a meeting at 7. So wherever you are driving, you are doing your other tasks. You don't need to you don't need to visit, to come to contact with your computer for you to know whether you are scheduled for a meeting. So you walk with it. It is part of your clothing, and it has that capability of giving you some common computer applications, but not all of them. Then we have terminals. Terminal is a computer usually with limited processing power that enables users to send data and receive information from a server or from a host computer. It is a thin client. A thin client is a terminal computer that looks like a desktop but has limited capabilities and components. Good example of terminals is the POS, which are used in businesses. Like you go to a supermarket and you want to pay using your Visa card. So when you give the cashier, they put in your Visa. So that gadget is what we are calling a terminal. So that gadget is able to send instructions to the server. The server, because the server is maybe in your bank. So once it sends instructions to the server, it's able to know how much money, get in terms of information, whether you are the one, the card belongs to that person, how much money, and when the money is debited, then that is the reason you see the transaction is successful. And even when you enter your PIN, that gadget is not the one which recognizes the PIN. The PIN is sent to the server where your account is, and is the one which authenticates or approves whether that PIN is correct or incorrect. So it's just a terminal, and we are saying it has limited processing power. It doesn't do much other than enabling you as the user, or even the cashier to send, even you send it, this is the PIN. So doesn't the information it sends, or even receive instruction, approval that this money has been, or this transaction has succeeded. And therefore, that's the reason you find you get updates that money has been debited in your account, or even the transaction is now successful. There was communication between that terminal and the server, which is the host. Another example of terminals is the ATM we use, the automated teller machines. These are self-service banking terminal that connects to a host computer through a network. So the terminal or the ATM whereby we go feeding data, it doesn't have much processing other than receiving our instructions that you can slot in your card. It asks you enter your PIN, you enter. So very few transactions, but much of the work it has to send to the server or to the host, and that is where information is authenticated, where information is stored and confirmed that yes, I want to withdraw 10,000. Do I have the 10,000 in my account? And when I withdraw 10,000, it has to subtract from what I have, and I have a new balance. That processing does not happen on the ATM. It happens on the host or the server itself. So the work of the terminal is to receive your instructions as a user and send to the server, and then receive instructions from the server and provide that information to the user or to the person who is using the ATM. So that's how they operate, and all those are types of computers. Then we have the embedded computers, and these are computers which are embedded on like on cars. For those people who drive, and maybe you visit a mechanic, you realize they are telling you there's a computer for the steering wheel. There's a computer for maybe the airbag. There's a computer for the pressure the gas pedal. And whenever, like when you are, especially automatic cars, when there's a problem, you realize there is an icon or there's a signal on the dashboard. That signal tells you what is the problem. And if maybe you are not sure and you take to a mechanic, the mechanic will tell you the computer maybe for the pressure, for the pedal pressure has a problem, or even has a virus. So those computers can get a virus the way our desktop, our laptops, our mobile phones, they can get virus. So even from the cars, for the embedded or the mobile, the motor vehicle kind of computers, it's a variety of them. Each system has its own computer which controls the operations of that system. If it's a airbag, like if there is a problem, then that computer which controls how a airbag operates is the one which is tasked with that kind of a work. If it is the steering wheel or what we call the cruise controls, there's a computer for that. So we call that, those are embedded computers because they are attached. There are several computer systems attached to various functionalities in a motor vehicle, and they are only specialized to control that activity or that operation. So that is what we call embedded computers. Then lastly, but not least, we have the mobile devices. These are also types of microcomputers. There is the on-screen keyboard. All these are examples of the mobile phones, mobile devices. Not only the mobile phone, but even like the virtual keyboard, like the portable keyboard, the slide-out keyboard. All those are types of mobile devices, and they are computers in their own sense. So those are the types of computers I wanted to share with you. And you can see now, starting from the mainframe computers and looking back at what we discussed last week on the history of the computers, you can see we have really come a long way. Mainframe computer, the idea of a mainframe computer started when ENIAC and UNIVAC were developed. And that idea is still under development, meaning that the processing speed, the size is being worked on, but the principle of large computers being able to serve many people at the same time and being used in large organizations, that is where I talked about computers started from. So that is still in practice today. You'll find that there are some computers which cannot be afforded by a person or by an individual because they are very expensive, they are very big, their processing speed or power is so high that it's not possible. You are actually wasting money by such kind of a computer. And that is where we had the mainframe computers. So they are still there today. However, its development and its use has now been limited to maybe data centers or what we call the cloud. So when you hear somebody say the data is in the cloud, it's not the cloud per se. It is in the data centers, whereby in the data centers you find there are majorly mainframe computers storing data for different organizations. So each organization, like, it's given its own computer or space, and they operate under that, on that space, another institution, another space, and all that. So it's upon the data center to allocate institution space, and also to make sure the space is available, it's accessible, there are no downtimes and another problem, because that is their service and nothing else. That is what they provide, or the service they offer. So those are the types of computers, unless there's a question, which I said, in case you have a question, please put it on the chat. I believe you can see where the chat is. So in case you have a question, always put it on the chat, and I usually leave the main screen and check whether there is anything on the chat to respond. But as per now, I can't see any question or comment, and I believe we are okay. So I want to move on to the next topic. And the next topic I want to share with you is now yes, introduction to computers. And basically, this is whereby I want us to look at what are the components of a computer. And in looking at introduction to computers, we say that computers are made up of two parts, the hardware and the software. The hardware is the tangible part of a computer system. Those parts whereby you can touch. We can term that as the hardware. The tangible parts of a computer system is what is called a computer hardware. So we have various parts. This is how it's organized. We have like the input devices. The input devices are the ones which you as a user, you enter the data, the letters, the numbers, the symbols, and whatever. Or even you click. When you click, you are issued an instruction. So input devices are used to enter data or enter an instruction. So that is one part of the hardware, and basically input devices, you can touch them. Keyboard being one of them, you can touch it. A mouse is another one, you can touch it. The screen is also an input device in case it's a touch screen, you can touch it. Then another part of hardware is the CPU, or what we call the central processing unit. This is how it is. It is actually inside the shell of the computer. There's the memory. The memory is whereby data is stored. There is the hard drive. The hard drive is also where you store data. The motherboard is the one which now houses the hard drive. It houses or hosts the memory, and also it hosts the CPU. Then there is the screen. The screen,
Excuse me,
or the monitor. Yes?
The screen, I don't know if you're sharing anything because the screen is stuck on introduction to computers.
Oh. And now?
Yeah, now I can see hardware and software. Thank you.
Which slide are you seeing now?
Computers are made of hardware and software. Basic PC hardware, yeah.
I don't know what is happening. Let me see. Are you seeing hardware organization?
Yes, I can see it.
Okay, let me start from where I lost you guys. So we had said I'm going to do introduction to computers, and I said there are two major parts which make up a computer, hardware and software. And I said hardware is basically the tangible part of a computer system, those parts which you can touch. And now this is where I was explaining, and sorry if you're not seeing because I was pointing at them, but I believe now you can see. I was saying in terms of hardware organization, we have the input devices. The input devices, I said, are those devices which a user uses to enter data or to enter instructions. So like use a keyboard to enter data, you type using the letters, the numbers, the symbols on a keyboard. So you are entering data into the computer. You can also use a keyboard or even a mouse to enter instruction. Like when you press the key enter, you are actually issuing an instruction. When you use the mouse to navigate or to move around and you click a particular icon, you click a particular menu, you click save. What are you doing? You are actually entering or you are issuing an instruction. So those devices which you use which are used by a user to enter data or instructions is what is called input devices. And those devices you can see them, or you can touch. Another another part of the hardware is the CPU. But before I talk about the CPU, let me talk about the motherboard. When you open, especially what we call the CPU, inside there is what we call the motherboard, and the motherboard actually hosts or holds the major parts of a computer. One of them is the central processing unit, like this. Also the memory used for storage, the hard drive, all those are hosted by the motherboard. There's now the monitor or the screen, and even the input devices. For them to work, there are some slots or ports on the motherboard whereby you have to connect for them to work. So this cannot work alone without being connected to this. This, even if it is external, it cannot work alone. It has to be connected to this. So everything is controlled from here. And that's the reason it's actually called the motherboard. It mothers everything. It's a board which has everything. So this is how the external setup of a computer looks like, what we call the hardware. So when you talk about the hardware, examples of what composes our hardware is the keyboard. You can touch it. The mouse, you can touch it, you can see it. A microphone, a speaker, the monitor, the screen, the system unit, which now has the motherboard in it, and another speaker. So this is how you can represent the hardware diagrammatically, or what composes the hardware of a computer. So the basic hardware of a personal computer are the following. It has a central processing unit, it has a memory unit, input devices, output devices, and secondary storage devices. We are going to look at each in detail. We start with the central processing unit. The central processing unit is actually what we call the brain of the computer. It is where interpretation of instructions happens. Without the brain, it will not be possible to respond. Same case to human beings. Without the brain, it's the nerve center of everything. In terms of instructions, if I want to lift my hand, it has to start from my brain that I need to do this. They issue the instruction that lift your hand, talk. It starts with the brain. So the central processing unit of a computer, it is the brain. So when you type, the brain has to instruct a particular, maybe the keyboard, that receive letter T as T. Then it also maybe instructs the storage that store this letter. And you issue another instruction like I want to save. It is the brain which will instruct the memories that you need to store these instructions. And actually that is the reason it is said it directs and controls the entire computer system and performs all arithmetic and logical operations. And this is how it looks like. The central processing units are just small components which are embedded onto the motherboard, but that is the work they do. The second unit, hardware unit of a computer, is what we call the memory unit. And the memory unit, it is where the programs and data are stored. So the work of a memory is to store, but they store two things. They store the programs and they store the data. So when you talk about the programs, these are the software. For instance, there's Microsoft Word. That's a software. That is a program on its own. The other programs like the operating systems, like the Windows, if you are using Linux, whichever kind of operating system you are using, that program, where is it stored? It is stored in the memory. Also, it also stored data. Data is that the document you have created. You have typed a Word document. That is, it contains data. You have entered a spreadsheet. You have entered the patient's details and you want to store. All that data is stored in the memory unit. In terms of memory, there are two types. There is the read-only memory and there is the random access memory. The read-only memory, it contains the pre-programmed computer instructions. What is, for instance, what we call the BIOS. So when manufacturers are designing or they are building a computer, there are some basic things which have to be installed for a computer to work. One of them is the BIOS. The BIOS is the basic input and output system. And this is very important. Remember I said for like if it's for the keyboard to work, the keyboard is an input device. For it to work, it has to be attached to the CPU or to the what we call the system unit. The output devices, for instance, we have the monitor, we have the speakers. The speakers is also an output device, but you need to connect it to the system unit for it to work. When for it to be connected, there has to be a provision for that part to be accepted and for it to work. Otherwise, if there was no, this is what we call the BIOS, you will connect and it will not be recognized. That is the reason you are able to connect a keyboard and you see the system is trying to install a new device. You connect the speaker and you see the system is trying to install a new device. Because, yes, the provision was made that you can connect the speaker here. But there has to be instructions that when a speaker is connected, what is the work of it? The work of it is to produce sound, the output sound, and not text. The work of maybe a screen or a monitor is to output text and not audio. So such kind of instructions are stored in ROM. And that's the reason we have said it contains pre-programmed. So pre-programmed means that program has already been programmed before. So it is not after. It's only a matter of installing it and it works because the program has already been installed before. So the read-only, the ROM comes when you buy a computer, either a mobile phone, laptop, tablet, or watch, the wearable computers we talked about. It has to come with a ROM. And in the ROM, there is nothing else. You as a user, you cannot store anything there. It is already made for pre-programmed. So already programs have already been made for it. Then we have the random access memory, and this is used to store programs and data that you will run. And it exists only when there is power. Now, what I'm saying is that RAM is not, remember I said memory unit is used to store programs and data. And specifically, these ones are stored in the random access memory. Even though we also have another memory called ROM, but I've said the ROM stores pre-programmed programs. And another thing to note about RAM is that it only comes into being once you power the computer. When the computer is not powered, RAM does not exist. So it is not recognized. And that is an example of what I was talking about, the random access. It is viewed data sent from the memory to the screen, and then the hard drive and all that. That is a diagrammatic representation of how it works, that data, documents, programs are transferred from the hard memory drive, sorry, to the memory. And even now, after being stored in the random access memory, it is sent to the screen from the memory, and therefore you see it as data whatever you see on the screen. So that's how it works. The other part of hardware is the input devices. And as I said, input devices translate data from the form that humans understand to one that the computer can work with. Like you are typing your assignment. You are typing using words you can understand. But the computer cannot understand that in that format. So there has to be a device which will translate what you as a human being understand to what a computer can work with. And that part or that device which does that work is what we call an input device. So it also allows data and programs to be sent to the CPU. Input devices allows one to send data and programs to the CPU. Examples of input devices include keyboard, mouse, joystick, microphone, webcam, and scanners. All those are input devices. We are going to look at it in detail. The keyboard, you are aware of the keyboard, but we have various types of keyboards. We have the traditional one. Many of you might not have seen this one, but I had the privilege of seeing it. The first one, this one. The first, what we call the traditional keyboards, are like, these are the numbers 1 to 10, sorry, 1 to 9. No, yeah, these ones. So the numbers were separate. The alphabets were separate. And now what we call the function keys were also separate. So that is how the traditional keyboard looked like. Not like today's, whereby you find the letters, the numbers are in one place. So if I want to use a number, I need to press shift and the number. Or if I want to use a particular function, I press shift and the particular button. Meaning a button has more than one functionality. But the traditional keyboard, everything was separate. The numbers, the function keys, the alphabets, the symbols, each operated on its own and they were separate. So this is what is called the traditional keyboard. We have now the flexible keyboards. I believe you have seen them. A keyboard you can even roll. You roll it up and put it on your handbag and you carry. So like if you have a tablet, you have a laptop, not necessarily laptop, but like the new technology of the desktops, the one I was explaining, you can comfortably use the flexible keyboards. Then we have the ergonomic keyboards, are the ones whereby they really take care of your palms in terms of the ergonomics. Because we might not go into that topic. You know that computers pose a health hazard. Like for those people who type a lot, you'll find that the joint between the wrist and the palm, it can get worn out, that joint, because of the typing. So we have keyboards which have come into the market, which take care of the ergonomics, or take care of that health hazard. Then we have the wireless keyboards, like the ones that I was explaining. You just need the Bluetooth device, and the keyboard, it recognizes the keyboard and you can work. We have the personal digital assistance keyboard, like this one. The phones, the mulikamwizis and the kambambes, they have their keyboard in them. Or the old phones we were used to, they had keyboards. So that is what we call a PDA keyboard. Then the ATM keyboard, you know how it looks like. That's also a type of a keyboard. So those are the types of keyboards. Then in terms of mouse, we have said a mouse is also an input device. We have various types of mouse, two actually. We have the, and I think now, yeah, we have two. We have the mechanical, and this is a type of computer mouse that has a rubber or a metal ball on its underside, and it can roll in every direction. So the navigation or the direction for you to point using a mouse, it is done using this rubber or this mouse, which is a ball like. So when the ball rolls, now it moves the pointer to wherever you want to take it. That is a mechanical. And you see something which is mechanical, it has to be, the work has to be done by a particular part. So for a mechanical mouse, it is this ball which is doing the mechanics of taking or pointing the mouse to whatever direction you want it to point. But nowadays, we have what we call the optical mouse. And the optical mouse uses a laser for detecting the mouse's movement. And this is now the optical mouse, whereby the laser or that light, you shall see a red light. That is the laser light. That is the one which now directs the mouse's movement or where you want to point. So that is the technology of the optical mouse. Other pointing devices or other input devices you can is the trackball. The trackball is this one has also been maintained even today in the optical mouse. When you look at the mouse, there is usually a knob at the top, a knob whereby you can fail to move the mouse, but you press or you roll that ball and the mouse moves, or without necessarily moving the mouse in totality, the whole of it. You just scroll or you roll that ball. That is what is called a track ball, and it is helping you to point. Then there is the track point. Remember when I was explaining about the structure of a laptop? I said on the keyboard of a laptop, you'll find these red point. It's also called a track point, and it helps you to point to specific areas. So you can also use it to point to an area. We have the touch pad. We have the touch pad, whereby it can also be used to point. The touch screen, touch pad, remember, like if you are using a smart card and you are told the biometric systems, you touch with your fingers and it's able to recognize it's you because already it is attached to a particular maybe host or server. So the touch screen, like what we use on our computer, on our mobile phones, all those are pointy devices. We have the joystick, and the joystick actually it is used for computer games. These are very famous input device for people who like play computer games. So this is what we call a joystick. We have the light pens, and these are light sensitive pen-like device which you can use to sign. You can use it to write, and I believe you have seen it in form of tablets. You can use it to write notes on your tablet the way you underwrite. So use it to underwrite on the screen. That is what we call a light pen, and it's also an input device. Then we have the stylus. The stylus is also a pen-like device, and it's commonly used with tablet, PCs, and the PDAs. Some phones come with this kind of a pen to also help you to either to write, to scroll, and to do other things. So those are examples of input devices. Then another hardware is the scanning devices. And in terms of scanning devices, we have various optical scanners, the card readers, the barcode readers, and the character and mark recognition. Starting with the optical scanners. The optical scanners are like you go to hotels. You go to hotels and you are given a card. No, sorry. Optical scanners are like what we have. The scanning images. You buy a scanner and you put something on top, and you see a light. When you press scan, it reads uses a light. That is optics. That is what we call an optical scanner. So the laser light is the one which reads or inputs what is to be scanned into the system, and you get an image of it. So that optical light is the one which is used as an input device. Then we have the card readers. The card reader is like, you remember when I said you use your Visa cards on a terminal. When you insert that card into the chip itself, the card is read. So the card reader now becomes an input device. You go to hotels and you're given a card to go and scan on the door and it opens. That's also a card reader. So it's also an input device. Then we have the barcode readers. The barcode readers, like I gave the example of the handheld computers, whereby and the barcode readers. You remember, like you go to supermarkets or even to a shop, and you pick an item and the barcode is read. That the barcode reader, or that device which is reading the barcode itself, is an input device, because it is reading what is on the barcode and translating it into the system. So if it's the inventory, you usually see maybe the inventory was, we had 30 packets of milk. So it reads this is one packet. Then it is subtracts. Now we'll have 29 packets. So that is how it is connected, because it is inputting the device, the information or the data from the barcode to the system. Then we have the character and mark recognition devices. And this one, you find them in banks. When you go to deposit a check, you find that you will see the teller putting the check on a particular machine. That machine is what we call the character and mark recognition device. On the check itself, like the example I've given here, there are some numbers here which can only be recognized by that device. So when it is put there, the check now is read and recognized that, is it a valid check? Is it a check number what? Issued by which bank? Or that. So basically that device is helping to input information about those characters and those marks. Another hardware is the image capturing devices, like the cameras. We have the digital cameras and the digital video cameras. I don't want to go into the details of those. Then we have output devices. Output devices, that is the media or the devices which the computers use to display the responses to the user requests or instructions. So that part of our computer which displays what the user wants to see. Like monitor, when you type, you want to see I've typed my name. How do I know that? I have to see it on the monitor. So it is an output device. The audio speakers, I'm speaking. So if I want to listen to my recording, what will I use? I'll use an audio speaker. So what is it doing? It is displaying the responses or the requests or the instructions. The printer is also an output device. So not much detail. I won't go into the details. There are various types of monitors, the CRT or the cathode ray tube. Those ones have already been overtaken by events, but they are still there. There is the liquid crystal display, the LCDs. Those are the common ones. And even nowadays, we have the curved. The printers, as I've said, they're also an output devices. And we have two types of printers, the impact printers and the non-impact printer. The impact printers uses pressure to physically strike the paper. So not to take you into the technical issues of printers, for you to know whether these are impact printer, those printers which make noise when they are printing, that is an impact printer. And that noise comes when pressure is applied between the printing element and the paper. When they come into contact, there is an impact. And that impact is the one which gives it its name, and it's the other one which makes that noise. So for you to know whether this is an impact printer, always see whether or hear whether it makes noise. So we have examples are dot matrix, the line printers, and many other printers. The other type of a printer is the non-impact. Now the non-impact, the printing element and the paper does not come into contact. So there is no impact. And one, you will not hear noise when these type of printers are printing. But instead, since they do not apply pressure on the paper, but instead they produce characters by lasers, ink spray, or photography or heat. So they use the technology of maybe spray, ink spray, the technology of laser, or the technology of photography, taking a picture, a photo, or the technology of heat. So when they use that to transfer the characters to the ink and to the paper, then that is what we call the non-impact printer. So look at your institution, look at the printers you visit, and when you find that it is not making noise, no, that is an example of a non-impact printer. Those are the photos showing. These are dot matrix. You'll find that it makes noise. A laser jet or laser printer, this one uses light to transfer. Then the inkjet. So these ones are non-impact. This is impact. Then we have the secondary storage devices. And secondary storage devices, these are attached to the computer system to allow you to store programs and data permanently for the purpose of retrieving them for future use. So flash disk, hard disk, CD-ROMs, those are what we call secondary storage devices. We have primary storage device, but this is inbuilt within the system unit. The RAM is what is called the primary storage device because it is the first place where data is temporarily stored when there is power. But when power goes off or you switch off the computer, the data is lost. But we have this provision of the secondary storage devices whereby you can use to store your programs and data permanently for the purpose of retrieving it later. So you can use a flash disk, you can have a hard disk. So hard disk has to be inserted into the system unit, and that is the part. If your computer does not have a hard disk, it's not possible to store data permanently or for future use. A CD-ROM, well, that's also an example of a secondary storage device. So this is diagrammatic representations of that. That is how a hard disk looks like. That is how our optical disk, or what we call the CD-ROMs, looks like. And we have other storage devices like the minis, the SanDisks, the USB flash drives. Those ones I know you are familiar with. So those also are storage devices, and they also form part of the hardware because you can touch, you can see. So basically, in summary, what builds up a system unit? Remember when I showed you the diagrammatic representation of a computer, this one. We have talked about the keyboard, we have talked about the mouse, the microphone or the audio as an input, the speaker as an output, the monitor or screen also as an output device, the speaker is an output device, but we haven't talked about the system unit. So the system unit contains many things. That's the reason it's called a unit. It has a casing or a cover, the outer body. It has power supply. It has a motherboard, microprocessor, memory, video card, sound card, all the way to modem. All these parts build up that small section or part I've shown you called a system unit. So starting with the casing, that is the outer shell. It houses most of the computer parts. Even though it is one of the most overlooked parts of the PC, it protects the computer circuits. Actually, it protects the clothing of what is inside. It cools the computer and the system organization. It provides the cooling. So it has the fan. So computers contain a fan. In case there is overheating, then the fan helps in cooling, and the fan is part of the case or the cover. The power supply responsible for powering every device in the computer. So for the computer to work, every part has to be powered. Remember, when you are talking about the computer generations, first, second, third, we talked about the circuitry. Started by, say, the first generation computers, where the circuitry was powered by vacuum tubes. So that is, what is that that device which allows power to be circulated among the various parts. So that is also a part in the system unit responsible for powering every device. Parts of our power supply, the disk drive connectors, the fan. So the fan cannot work if there is no power supply. The power switch, the cover, and the power plugs, which are the receptacles. Then the motherboard. This is the physical arrangement in a computer that contains the basic circuitry and the components. The components in a motherboard, I had even explained before, includes the microprocessors. It also has the core processors, which are optional. It has the memory. It has the BIOS, or the basic input-output device, the system which I've explained in terms of ROM, what happens there. The expansion slot. In case you hear that somebody say, I want to expand the storage of my computer, that is possible if the motherboard has a slot for expansion. I want to expand the processing speed. I want to add another processor into my computer for it to have more processing speed. That is only possible if the motherboard of that computer has an expansion slot. So that is the work of that. Interconnecting circuitry. So all these components are the ones which are found in the motherboard. And this is how it looks like. It is actually very complicated, but it's something like this. Just know that it has a port whereby when you insert your USB, that USB, unless it has a provision, a port, whereby it has to be connected with the motherboard for it to work. The socket, when you connect power, there has to be something on the motherboard and many other things. The expansion slots I was talking about include the graphics cards, sound cards, modem cards, and the NIC, or what we call the network interface cards. I want to explain this because it's also good for us not to be so naive or maybe ignorant in terms of some of the technologies or technical terms used by IT technicians. You will find that maybe your computer has a problem. Maybe it cannot produce sound, the audio, or it cannot show images. You realize that there can be such problems if your computer does not have a card for sound. And when you take it to the technician, they tell you, I've inserted a sound card, and the computer now can produce sound. You can hear, you can listen to music, You can listen to lecture recordings. This is possible because if it was missing a sound card in the motherboard, there was a slot for a sound card to be slotted, and then it solves that problem. You get another problem like your computer is not able to be connected to Wi-Fi, or even when you connect to the network, the Ethernet, it is not able to recognize the network. Your computer might be missing what we call the network interface card. So the technician will only put a card, but the card there has to be a slot for NIC. NIC is a network interface card. And when it is slotted and you connect your Ethernet or even your Wi-Fi, then you are like, wow, my computer is now connected to the network because it was only missing that card. And those, but provided it comes with the expansion slots for those cards to be inserted or slotted, then it's possible for your computer for such a problem to be solved. So those are that basically forms our discussion about the computer hardware. We started by looking at the types of computers, and we linked them to our discussion of the history of the personal computer, looked at where the mainframe, where the mini computer, and where the microcomputer came in. And now we have just finished looking at the first component of a computer, which is the computer hardware, looking at the various tangible parts of a computer, starting with the CPU, the motherboard, the input devices, the output devices, and all that. So we were able to see the hardware. So next time, since I want to stop there, is we look at now the computer software, which is the second component of a computer system. Thank you so much. I wish to stop there unless I can, from the chat, let me see. From the chat, I can't see any question other than Tonui telling me, kindly avail to us these notes in a printable form. Very informative. I want to respond to Tonui. Maybe I didn't make this clear to you last week that I will be sent once, as I said, this is recorded. So after the recording is over, I have to upload it onto YouTube. Then I share with you. That is one. Secondly, I will be sharing these PowerPoint presentations. These PowerPoint presentations, you'll get them from the section of files. If you go to Microsoft Teams, and I want to put you that is a challenge, that go to Microsoft Teams. That is the link I sent you. You'll see two sections. One is the post, not two, but three. Or like the posts where I can see Tonu, you have given me that comment. The second tab is files. If you click on files, that is where you'll find the PowerPoint presentations for last week. So that is where I'll be uploading. So I did upload in this. Okay, sorry, I'll upload in this. I uploaded in another channel. But under files, that is where I'll be uploading the notes for your future reference. So because I can't, it's not possible to send all these notes to each one of us's email addresses. And I realize some groups, they have not put me in their WhatsApp group. I will not, I will not, I don't know the reason, but it's okay because I have to use the official communication channels, which I'm okay. But if I was in your WhatsApp group or even in your Telegram channels, it will be very possible to share the notes very easily. However, look at the file section under Microsoft Teams and you'll be able to download the PowerPoint. Actually, I put them now in PDF. The PowerPoints, I put them in PDF format and I upload them under file section and you'll be able to download them from there. Thank you so much. Without another question or comment, unless I give any one of you to maybe, anyone who has a question, maybe can unmute. Any comment? Okay, I don't think whether there is any comment, so I wish to stop there and I want to wish you a good night and a blessed week. Bye-bye. See you next week.
Bye. Thank you, Mwalimu.